industrial processes including manufacturing, biopharmaceutical, and oil and gas operations, hazardous energy can turn routine maintenance into a life-threatening event, such as unexpected startup, stored pressure, and residual energy releases. These risks must be controlled systematically. This is where lockout-tagout, also known as LOTO, becomes very important. LOTO is a system for controlling hazardous energy during servicing and maintenance operations, but effective LOTO is not just about locks and tags. It is about understanding and managing risk. Under CSA Z460 and OSHA 1910.147, risk assessment is embedded throughout the entire lockout-tagout lifecycle. It determines the level of control required, the complexity of procedures, and the safeguards needed to protect workers. A strong lockout-tagout system begins with program development and early risk assessment of the process. The steps involved include: Step 1. Define the scope. Identify all equipment requiring energy control. Step 2. Perform initial risk assessment. This evaluation should consider equipment complexity, number of energy sources, frequency of intervention, and potential severity of failure. This early assessment determines whether equipment requires simple lockout-tagout or a more complex multi-step isolation procedures. After the program development and initial risk assessment, the next step is the actual field verification. This is where detailed risk assessment takes place. The assessment teams, which include the system owner, process, maintenance, health and safety, and operations, walk down the equipment to identify all energy sources, confirm isolation points, and detect hidden or stored energy. During this stage, the team assesses: what could go wrong? What happens if isolation fails? And if there are shared or interdependent systems. This field verification step is vitally important in the lockout-tagout process. In complex facilities, missing a single energy source can result in catastrophic consequences. Lockout-tagout are not generic, but system-specific procedures. They should reflect the complexity of the process and equipment, and should be based on risk assessment. Each step in the lockout-tagout is defined based on hazard severity, energy type, and system interactions. Every procedure must include equipment identification, shutdown steps, isolation sequence, lock and tag application, stored energy release, and zero energy verification. Additional controls, based on risk which could be implemented, include double isolation and bleed, mechanical blocking, electrical grounding, and group lockout systems. Lockout-tagout. Placards should be used to translate these procedures into clear, visual, and field-ready instructions. Before implementation, the lockout-tagout procedures must be field-tested and validated for performance and safety. This field validation is an essential component for any safety-critical procedure. By conducting the trial lockout-tagout, the team is able to confirm all energy sources are controlled, identify gaps or missed hazards, and evaluate any potential human factors issues associated with the procedure. This step is where risk assessment is validated in real conditions, not just on paper, but actual field validation. Training is a core component of lockout-tagout procedure, since the standards requires that role players' competence be aligned with risk associated with the equipment or system. Lockout-tagout training must be based on the worker's role as defined in the standard. Authorized employees perform lockout-tagout procedure. Affected employees understand hazards associated with lockout-tagout. Supervisors enforce compliance with lockout-tagout procedure. Lockout-tagout implementation for higher-risk systems should involve the use of group lockout, application of permit-to-work controls, and increased supervision and verification of the lockout-tagout procedure. Lockout-tagout is a living system which must undergo risk-based revision and update to comply with safety requirements and the standards. This is a life cycle approach specified in the standards and regulations. Risk assessment associated lockout-tagout procedure must continue after equipment changes, following incidents or near misses, and during audits and inspections. Lockout-tagout requirements must be considered as part of Management of Change (MOC) process. Use Management of Change (MOC) to reassess hazards, update procedures, and maintain accuracy of these procedures. Unreviewed procedures equals unmanaged risk.